Welcome back. So last time I was in a bit of a hurry and I didn't get to do this overlay on the video for you, so here it is now. You can actually see the speed on there that I was doing on that run up the runway, and it's a bit difficult to see, but down on the Garmin there it actually indicated about 35 knots was the maximum that I got up to here. And as you'll see over here, I think it shows like 29 miles an hour. So one's from the GPS, the other's from the pitot tube. So I'm not sure which one to believe yet, but probably a mixture of the two. Anyway, I wanted to show you that. So then I'm going to show you the overlay, or just the output from the engine ECU for just this little bit of a run. It's actually really encouraging to see, because now that the aircraft is moving, and this is for the first time really doing a run and getting some data where there's air moving over the engine, actually saw really good results compared to what I've seen when it's just been a static run where you're just sitting on the ground there, because normally when you run it statically, the heat coming off the engine just basically gets sucked into the engine, and so it gets warmer. Anyway, you can see there me ramping up. This is just when I went up the runway there. And if you look through the data there, you see that the boost was taking a while to come in, and then all of a sudden there was this big ramp of boost, and that's when I backed off the power, because having a turbo in my car, I know what it's like. When the turbo kicks in, you can get a real boost of power, and I didn't want to get to anywhere near flying speed. So you can see the temperatures are really good there. Actually, the intake air was almost the same as ambient. So, again, it wasn't a very long run, but the same length of run just on the ground there, when I'm just sort of running it up like that, you end up having much higher temperatures. And likewise, the EGTs didn't even get up to 1,000 there. So, and it was quite a lot of load on the prop, and it showed like 13 gallons an hour, which is about 260 horsepower. So, yeah, I'm actually really encouraged by seeing this. Once we have the cowling on and we're getting better air flowing directly into the engine, and obviously get a little bit more airspeed up, I think there's going to be a lot of power boost there with keeping low EGTs and also low temps on the intake. So moving on, Mark has finished with the redesign of the new oil shuttle. So just to show you, this is the feed line going in there through the existing housing, and then there's two return lines coming out, and he's sort of designed them there at different lengths, so it's easy enough to get them connected. And so if I give you a little cutaway view here, you can actually see what's going on in there. So the new shuttle there is basically smaller than the housing. So there's the feed coming in there, and it goes into the shuttle through there, and then of course that oil sort of wraps around where the prop is, or where the prop shaft is there, and it feeds through that hole there down into the prop. And then when you want to back off the pressure there, it goes through these little close tolerance areas right there and there, and into those sort of channels on either side of the main channel. And then down the bottom from those channels, it can drain out back into the sump of the engine. And as you can see, the shuttle itself is smaller, so it actually rides on the shaft. It doesn't live, it's not like touching the housing. And how it rides on the shaft is these just regular ball bearings, sealed bearings there. So there's one of them there. Again, we're just in the cutaway view. And there's the top half of it there. And there's another one on the other side. So this way, if the shaft moves at all because of the tapered roller bearings, the shuttle will move with it. So those close tolerance areas, there's no way for them to actually hit the prop shaft at all. So that's what the shuttle looks like there, just hiding a few of these different things. And there it is, and then you can see there's one of the sealed bearings on the side there. And that's the big tapered roller bearing you can see there now. But anyway, there on the side there's with one of the sealed bearings that it rides on. So the only parts we have to have machined is a new shaft and then the shuttle, and then both of these are now been we've sent off the PO to have both of these done. So this is what the shuttle looks like, and hopefully they'll be done and back by just around the time of Oshkosh finishing, because I've decided now that I absolutely want to have the constant speed prop working for the first flight. We really need to have the best performance we can out of the engine and prop setup. So there's a cutaway there of that as well, so you can see that. Anyway, so that's going to delay our first flight, but it'll just mean that we're better prepared for it. And you only get one chance at a first flight, so let's make it a good one. And now moving on to fixing the Carnage from last time, you can see I've actually removed the Elpex out of there. There's the outside housing and all the rubber from it, and there's the actual rubber thing itself. And you can see the centerpiece is not there, obviously. You'll see it in a second. And it pretty much got destroyed, and I really think it was just undersized, even though it was the biggest one we could find and rated for the highest power. And there's the inside part of it. So anyway, I was in a bit of a panic when this happened, because I knew that Siemens didn't actually have a replacement for that. But as fortune would have it, one of the local guys down the end there where we are at the hangar, he came down, had a look at it, and then 20 minutes later sent his one of his friends down who was just at the airport. Turns out a nice Kiwi guy who's been living over here for a long time and into race cars and stuff, and got to talking with him a little bit, and showed him our little problem, and he's looked at that and he goes, "Oh, I got one of those things or something like that on my dyno." And I'm like, "You're kidding, right?" And he's like, "Oh no, it's just like that, except it's better, And I'm like, "Really?" And so tell me more. And anyway, he went through and told me what he had, and he couldn't remember the name or the brand of it, but invited me down to his house to go and have a look at it. And so I had my lunch and went down there to have a look at it, and sure enough, he's got exactly what we need. And it's turns out to be a Lord product, which is a big company that makes all kinds of different things. And anyway, so I'll show you that in a second, but I've gone and looked it up online and got the specs and got the dimensions, and it's going to fit beautifully for what we need, and it's much stronger. And that's what it looks like on his dyno there. So similar type of dimensions of what we have, but that rubber section there is literally more than twice the thickness of what we had. And it's designed there that if it's over torqued, it will actually slip in that metal housing. So if you got a prop strike, it wouldn't be a problem. But anyway, you'll see more of that because I've ordered it, and it'll be here next week, and I've got to do a few mods on it, and then we'll get it installed. Anyway, so moving on to fixing problems now. So there was quite a bit of play in these side sticks because of the problems that I had a while back when I was trying to make these things work smoothly. So what I'm doing now is I'm going to be changing those bearings in there to metric, going from imperial to metric, and that way I can just upsize them a little bit and open up those slots just a little bit more, but have the bearings fit tighter. And likewise in these, Len had also recommended that those little nylocks in there be changed to castle nuts with cotter pins, because they're rotating. So there you can see I've done one of them already. I haven't bent the pin there yet, but that's what that looks like. And these are the things that belong on the end of the sticks and connect to the elevator torque tube via a bell crank, so you can actuate the elevators. And then that's what it looks like there with the cotter pin bent around there. So that was a quick fix, getting those done. All that takes a little bit of effort to get all that out of the back there, because now I'm pulling apart part of the dash. But you got to have this thing safe, and I also want to get rid of the play in the various different areas of the controls and make it nice and tight. So yeah, that's how that one looks like, and the other one yet to be done. So just moving along with that, and you see it still rotates nicely around there through that pillow block bearing, and then that just gets bolted onto the end of the stick there and behind the dash. And here Jeff has bonded a little stick there onto the bottom of the fuselage, and you can see it flexing there when he moves the aileron up and down, and the other one is locked in place. So that's the problem that we're having with those pulleys actually flexing. So we're still figuring out exactly how we're going to stop that from happening, but it is a big problem. So anyway, at least he has a good way now of seeing it, if it's fixed or not. And Devon's been working on getting the last of the access panel covers all done. He's got these ones cut out of some existing flat stock that we had, and he's got them cut and fit to shape and drilled them, and he's also putting the nut plates in where they bolt up to. And another project Jeff's working on here is creating a little fixture there that can bolt around the midpoint of the winglets, one side and the other side, and then he's got some cable there. He's going to pull them together and be able to actually flex or pull the winglets together and see if the wings actually twist at the same time, because we don't want them to twist at the tips when the winglets are flexed in. So this is a couple of 2x4s that he's going to cut out the shape there and bolt them around the winglets using this cable and then a crane scale so we can measure the load holding it together and then see if there's any twist. And I didn't get a lot of other footage of other stuff that I've been working on, but I've been working on getting the doors now to shut correctly, because that's always been something that I've had to do. And again, just getting the flight controls all tidied up and so there's no play in there. So quite a lot of just fixing little things, and as we knew, you know, once you start testing, you start finding problems, and then you got to fix everything. So yeah, it's going to take a while to get everything done. But in the meantime, also too, I wanted to let you know that I've been in touch with Justin Gillen, and it sounds like him and Elliot Seguin are going to come out and probably do our test flying after Oshkosh, and I'll be having a conversation with them hopefully over the next week. They're up in Wisconsin right now doing some work. So that's good news. And anyway, I'll leave you guys with most of the run there from the other day. If you're not interested in watching this goes to the end of this video. Then you're more than welcome to tune out. Otherwise, enjoy this, and we'll catch up with you guys next week. And thanks again for watching.